Hello student, welcome to the online tutorial session. Today we will start the chapter number 3, Boolean Algebra. What is Boolean Algebra and who invented it? First of all, we have to know these things. Mathematician George Boole invented a new kind of algebra of logic, in the year 1854. Popularly known as Boolean algebra or switching algebra. He stated that symbols can be used to represent the structure of the logical thoughts. Boolean algebra differs significantly from conventional algebra. Conventional algebra means in mathematics, what kind of algebra you are doing, that one is called conventional algebra. This algebra deals with the rules by which the logical operations are carried out. Here, a digital circuit is represented by a set of inputs and output symbols, and the circuit functions express as a set of Boolean relationship between the symbols. So, what is Boolean algebra? In detail, if you try to analyze, then we have to learn two things. That is, one is logical constant and another one is the binary valued variable. Logical constant. So, a statement having a true value or false value is known as a logical statement. It means that the statement will either can take true value or transmit false value. True or false value means either it can take 1, that is as a true value, and 0, that is as a false value. The truth value of a logical statement may be true or false. These are called the logical constant. Okay. The two logical constants, true or false, are usually denoted by T and F. If it is a statement is true, then we have to denote by capital T. If it is false, then we can denote it by this F. Okay, but at the same time, both cannot be true and false. Okay. Now, one single statement having both the value true and false, it cannot be possible. Okay, either it will take false value, either it will take true value. Okay. Next one is the binary variable. Okay. So a quantity whose value may differ during the execution of the process is known as the variable. Okay. Then what is the binary variable then? So a variable which is capable of taking only two value is known as a binary. Because binary, I have explained, binary means 2. Okay, bin means 2. From that binary concept comes. So a variable which are capable of taking only two values, then this kind of a variable is known as the binary valued variable. So what are these two kind of a value? Either it can take true value or either it can take false value. It means either it can take 0 as an input or 1 as a input. So what is the binary variable? How it is look like? That is a b whole bar. We can say it is an example, or you can say a bar b plus c. This is actually the expression. But however, you can represent it, the Boolean variable is using the combination of variable, like the example I have given. But you cannot write as a minus b, because a minus operator, these things are not included in Boolean algebra. So ab you can use, but a minus b, this kind of expression, okay, not allowed. A minus b, a dash b, this kind of a Boolean expression is not allowed. Okay, a minus a dash b I am talking about. This kind of a expression is not allowed in the Boolean expression. Then we have to learn about then what kind of a operation we can perform in Boolean algebra. Okay. So first understand this Boolean operators. Okay. So ordinary algebra deals with arithmetic operators like plus, minus, multiplication and division. Similarly, the operators used in Boolean algebras are not, and or. The operator is not actually a unary operator. Okay, so and rest of the two, that is and or, it is called a binary operator. So we have to know first that why the not is called unary operator, and is called a binary and or is called a binary, because in not operators operates only on a single variable, not on a double variable. Okay, it will take only a single variable. Okay, that is example is given over here. That is symbol is slash. On the top of the expression you can give slash, that is a bar, or you can directly strike out, that is on the above of the letter you can give a bar. So bar or this slash, you can use both the symbols is there. So it is operated is on only a single variable, Boolean variable. But in case of and or, if you are able to see, then you can notice that here two Boolean variables are included, that is a b or b c, x y x, this thing. So when two variables, binary variables are included over here, then that is, for this reason and or is called the binary operators. Okay, because it is connected to two Boolean variables to produce a new variable. Okay, so this whatever table I am making, this is also available in your book in page number 71, table 3.1. You can go through it. The three of them, how many operators are there over here? Three operators are there. That is, one is not operator. Not operator symbol is bar or slash, like we can give a slash or a bar. Second one is what? That is and operator. That is dot and operator. Dot. This a dot is a symbol of multiplication. That's same thing. Dot we can give, or this symbol we can give. Okay. So a dot b or a and b. This is the example. In the both way you can represent. And third one is or. Or implies you can say, can give a directly plus sign or this symbols. Okay, this one. Okay, so if you are applying over here with the two Boolean variable, then what will get it? That is a plus b, or a or b. So not you, if you use the not operator, what result you will get? You will get the whatever input you are given, just opposite output you will get. Okay. In case of and operator will work how? That if you are using and operator, then whatever Boolean inputs you are giving, it will multiply both the inputs and give you the result. Okay. And in case of or operator, if you are giving if you are applying or operator on a Boolean variable, then it whatever input you are giving, okay, that it will add it and give you the sum up result of this both the inputs. So not for the complement, to get the complement of the input and to get a product of the input, and or is for the get the sum of the input. Like other in and on or not operation, not gate, has you have learned the same kind of a functions they are actually making. Okay, in the next session we will learn about the Boolean operation. Thank you, student. I'm ending my lecture over here.